Good morning students, welcome back to Share the Maths channel. Now this is the continuation video of the binomial theorem inter secondary maths 2A and class 2. So already in the yesterday class binomial theorem introduction I explained some most important formulas that are used to solve the problems of the binomial theorem first exercise and also which are very useful to solve this theorem also, to prove this theorem. Now here in this video I start the binomial theorem proof. And this is a very important essay question, most important question straight into binomial theorem. Okay, most expected 7 marks question. Okay, all of you practice this question very well. This is the important one. Okay, let us start the class. Statement. What is the statement here? Already I explained this statement in the yesterday class also. It is the statement x plus a whole power n is equals to nc naught into x power n plus nc1 into x power n minus 1 into a power 1 plus nc2 into x power plus nc2 into x power n minus 2 into a square and so on plus ncn into a power n and so on plus ncn into a power n. Okay, this is the statement. Now how to prove this theorem? So here we prove this theorem by using the mathematical induction. Okay, by using the mathematical induction concept we prove this theorem. So I am writing that one here. We prove this theorem by using the mathematical induction. Now what is the mathematical induction procedure? First we have to show that the result is true for the n is equals to 1. Okay, all of you, I think that all of you know that about the mathematical induction concept. Already you solved some problems that are related to the mathematical induction in the first year, intermediate first year maths 1 year maths topic. In the maths topic in the second exercise we will prove 3 problems by using this mathematical induction. Okay, just remember that concept and apply that concept here. So what is the first step here? We have to show that the result is true for n is equals to 1. Now how to prove that result? Simply first take the n is equal to 1. Okay, understand all of you? First simply I am taking the n is equals to 1 and I am substituting that this n is equals to 1 in the and I am substituting this n is equals to 1 in the LHS ones and in the RHS ones. Okay, see here. First I am taking that LHS here. What is the LHS of the given statement x plus a whole power n? Now in this statement I am replacing that n is equals to 1 here. So it returns the answer x plus a whole power 1 and that is equals to x plus a. Okay, this is the answer of the LHS. Now take the RHS and in the RHS also substitute that n is equals to 1. Okay, that is n c naught. N is equal to 1 means 1 c naught into x power n, but n is equals to 1, x power 1. Okay, plus 1 c1 into x power 1 minus 1 into a power 1. Okay, what will be the next step? 1 c2. That value is not existed here. Why? Because we have to take the first value as the max value of the second value. Otherwise, if we take the second value as the max value, then that value does not exist. 1 c2, 1 c2, 1 c3, 1 c4, these values are not existed since here the second value is greater than the first value. Okay, so you have to take the series values up to this one only. Since 1 c1 this value is existed, after that all values are not existed here. So we don't take the remaining terms of the series here. Okay, now this is equal to. Now what is the answer of these two terms here? Already in the yesterday class I explained that what is the value of the 1 c naught. When we have the c naught, then directly you can take the value is equal to 1. Okay, already I explained that the formula in the yesterday class. Okay, 1 into x plus 1 into x plus similarly 1 c1. All this is also explained. 1 c1, if two values are equal then only that value becomes 1. Okay, 1 c1, 2 c2, 3 c3, like that. X power 1 minus 1, x power 0, x power 0 equals to 1 into a. So 1 into x is equals to a and 1 into x is equal to x and 1 into a is equal to a. So LHS value is equal to x plus a, RHS value is equal to x plus a. Therefore LHS is equals to RHS. So the result is true for n is equals to 1. Okay, therefore here we write the statement as the result is true for n is equal to 1. When we take n is equals to 1, we get the same value, same answers for the LHS and RHS. Okay, after proving that the result is true for n is equal to 1, what we have to do here? Now we have to assume that the result is true for n is equals to k. That is the next step. Okay, understand all of you? Now here after proving that, we assume that the result is true for n is equals to k. The result is true for n is equal to k means simply we substitute that n is equals to k in the given statement. Simply take the given statement here and in this statement we substitute that n is equals to k. That is, so the result becomes here, x plus a whole power k is equal to, here I am replacing that n is equals to k, n c naught, that is k c naught, into x power n, that is x power k, plus n c1 k c1 x power k minus 1 into a power 1, plus k c2 x power k minus 2 a square, and so on so on. Last value kck into a power k. Okay, this is the result like that. So here we are assuming that the result is true for n is equal to k, means simply we substituted n is equal to k in the given statement. Okay, now we have to show that the result is true for n is equal to k plus 1. Now to that, what is the procedure? So up to here the theorem is very easy. So up to here the theorem is very easy. Now it is enough to show that the result is true for n is equal to k plus 1. So we have to form the n is equal to k plus 1 in the given statement. That is the required result here. That is the required answer. So first, for that I am multiplying this equation by the value x plus a on both sides. Okay. Simply first in the next step I am multiplying this entire equation by the value x plus a on both sides. That is, x plus a power k into x plus a is equals to x plus a into, write this value, kc naught into x power k plus kc1 into x power k minus 1 into a power 1 plus kc2 into x power k minus 2 into a square, and so on so on. The last value is kck into a power k. Okay, simply I multiply this entire equation by the value x plus a on both sides. Okay. So this is x plus a into x plus a power k into x plus a is equals to x plus a power k plus 1. Okay, here bases are equal, power should be added, k plus 1. So this is equals to, now here we are multiplying the values. So how to take the product? Okay, listen, x into first value plus a into first value. Okay, next x into second value plus a into second value. Okay, next x into third value plus a into third value. Okay, and last x into last value plus a into last value. Okay, that's the procedure. Okay, listen, this is very important. If you know this part, then you can easily solve this question. Okay, this is the only difficult part of this theorem. Okay, listen, x into first value, what that returns, kc naught into x power k into x, understand, plus a into this value, that is kc naught into x power k into a, understand, x into first value, a into first value. Next one, x into second value means kc1 into x power k minus 1 into a power 1 into x. Okay, kc1 x power k minus 1 a power 1 into x. Next value, second value into a, that is kc1 x power k minus 1 a power 1 into a. Okay, now coming to the third value, x into third value, x into kc2 into x power k minus 2 a square. Next value, a into third value, that is a into kc2 into x power k minus 2 into a square. Now coming to the last terms, okay, see here, last value into x, that is kc plus kck into a power k into x, and last value kck into a power k into a. Now this is equals to, so x plus a power k plus 1 is equals to, okay, write the first value. What is the first value here? Kc naught into x power k into x power 1 is equals to x power k plus 1. Okay, this one here, x power k plus 1. Next, kc naught into x power k into a, okay, plus kc1 into x power k minus 1 into x, that is, this is 1 here, k minus 1 plus 1 becomes only k, x bases equal, powers, add the powers values, k minus 1 plus 1 with that returns only k here. Okay, x power k a power 1 plus kc1 x power k minus 1 into a power 1 that is equals to a square, plus kc2 x power k minus 2 x power 1 bases equal, add the powers, this is 1 here, k minus 2 plus 1, k minus 2 plus 1 is equals to k minus 1, x power k minus 1 into a square. Okay, and so on so on. Okay, leave this value and so on so on. Write the last value only here. What is the last value? Kck into a power k into a is equals to a power k plus 1. Okay, in the product just I am leaving these two values here to get the answer. I mean I am placing these two values in the tutos here. Okay, so this is equals to kc naught into, now this is kc naught into x power k plus 1. Okay, plus, so here from the second and third terms what we have to take common here, x power k into e, x power k into e. In the second and third values we have the value x power k into 1, k into a common. So take that value common, then what will be the remaining values? kc naught plus kc1 into x power k into e. Okay, plus, now see these two values 4 or 5. Okay, from the 4 and 5 values what are the common values? X power k minus 1 a square, that is this is x power k minus 1 into a square into, so this is kc1 and the next value kc2. Okay, and so on, plus the last value kck into a power k plus 1. Okay, now this is equals to, now here to get these two answers just I am applying one formula here. Already I explained this formula in the yesterday class. The formula is here. What is the answer for NCR minus 1 plus NCR? What is the answer to this one? Already I explained this formula in the applications also. N plus 1 CR. Okay, that is, here we have the same value n. R minus 1, R means these two are the consecutive numbers. Then what have to take your answer is equals to, just add the one number to this n value here. Then it becomes n plus 1. Okay, R minus 1 R, what is the maximum value? R here. So answer will be n plus 1 here. Take one example here. What is the answer for 10c3 plus 10c4? What is the answer to this one? 10 equals, so take the value 10 plus 1 here in the answer. 3, 4, what is the maximum value? 4. So answer is equal to 11c4. Okay, this is the formula, the very important formula this one is. Okay, so this is equals to, so write the first value here. First value is equals to kc naught into x power k plus 1. Okay, now what is the answer for kc naught plus kc1? See here, k say a number 0, 1 consecutive. So what will be the answer? Add the number 1 to the k, then what it returns? K plus 1. Okay, add the number 1 here, then it returns k plus 1. See, 0, 1, what is the maximum value? 1. So that's all, this is the answer, k plus 1 c1 into, this is x power k into a. Okay, plus, see the next one, so this is x power k minus 1 into a square into, see here, kc1, kc2, k same value, write the k plus 1 here, c, 1, 2, what is the maximum value? 2, that's all, that is the answer, and so on, the last value is here, kck into a power k plus 1. Okay, now this is equals to, in the next step I am converting these values as here. Okay, see here, therefore the answer of x plus a power k plus 1 is equals to, okay, kc naught, in place of kc naught I am taking the value k plus 1 c naught. What is the value of the k plus 1 c naught? That is equals to 1. Since it is c naught, what is the value of the kc naught? That is equals to 1. kc naught or k plus 1 c naught, whatever the value, since it is a c naught, that value becomes 1. So in place of this kc naught, just simply I am substituting that k plus 1 c naught. Okay, into x power k plus 1 plus the next value k plus 1 c1 into x power k. I am taking this k as the k plus 1 minus 1. Understand? Just I am adding plus 1 minus 1 to this one like that into a power 1. A is nothing but a power 1. Okay, plus write this value first. So this k plus 1 c2 into x power k minus 1. I am taking that k minus 1 as the k plus 1 minus 2. What is k plus 1 minus 2? That is k minus 1. Okay, 1 minus 2 into a square and so on. The last values. Okay, see here. Here we have the value kck. But what is the value of the kck? Two values are equal, means that value becomes 1 here. But in place of kck, I am taking the value k plus 1 k plus 1 c k plus 1, since this is also equals to 1. What is the reason why we are converting these two values in terms of the k plus 1? Since here we want the k plus 1 all the terms here in place of n. So to get the k plus 1 term in all the places, I am converting the first and last values like that. I am taking the kc naught as the k plus 1 c naught and kck as the k plus 1 c k plus 1. Okay, into a power k plus 1. Okay. Now check this result with the given statement of the De Moivre's theorem. First I am writing the De Moivre's theorem. First I am writing the binomial theorem statement here. Okay, see here. First check this answer with the binomial theorem statement. First I am writing the binomial theorem statement here. What is the binomial theorem statement? X plus a whole power n is equal to nc naught into x power n plus nc1 into x power n minus 1 into a power 1 plus nc2 into x power n minus 2 into a square, and so on so on. The last value is ncn into a power n. Okay, now check these two results. Now simply take that k plus 1 as n here. Simply just assume that this k plus 1 as n here. So x plus a power n, where n is equal to k plus 1, and c naught n is equal to k plus 1, x power n equals to k plus 1, and c1 n is equal to k plus 1, x power n minus 1 a power 1 plus n c2 x power n minus 2 a square plus, and so on so n cn a power n. Okay, just simply read that k plus 1 as n. Just read this k plus 1 and as n, then you get the binomial theorem statement. Okay, simply take that this k plus 1 is equals to n, then you get this result. Therefore, the result is true for n is equals to k plus 1. Since here we get the k plus 1 value in place of the n here, therefore the result is true for n is equals to k plus 1. Okay, therefore hence by mathematical induction the result is true for all n belongs to n. This is the hence by mathematical induction the result is true for all n belongs to n. Therefore, so the theorem is proved here. Therefore, the result is x plus a whole power n is equals to nc naught into x power n plus nc1 into x power n minus 1 into a power 1 plus nc2 into x power n minus 2 a square, and so on. So the last value is ncn into a power n for all n belongs to n. The most important theorem, very easy theorem. When you practice this part, then easily you can solve this theorem. Okay, understand all of you, and I will continue the remaining sums in the next video.